Hello. We will talk about etching process, and we'll focus on wet etching. First, isotropic and anisotropic etching. Isotropic is etching process at e- equal on both horizontal and vertical direction. So like this is equally. So this like on circle. Uh, then anisotropic etching is etching at one direction. So like this. Uh, in nowadays, uh, we 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 can get this bridge like this process first silicon and germanium and silicon and germanium and silicon. Then uh then we the next process is etching. uh then we want to erase germanium layer, so we can we call this sacrificial layer. Then before we etching, we regross the silicone like this because um, these silicones can't fly. So we gross the silicone, and this is mask, and we can we use wet etching. Then we this if we erase this only this germanium layer, so we should we should use this isotropic etching. Then we use etchant that that affect only germanium. Then these germanium layers erase etching like this, and we finally we get this bridge. Okay. The next, wet etching and dry etching. Uh, Before we talk about wet etching in this process, wet etching is uh, generally in isotropic etching. Then it it need only etchant of certain material affect of certain material. So it's easy and cheap, but it has an advantage. Uh, if we use etchant, so if we, etchant is remain after etching process, so it still still be having an impact to wafer. So if we use a rinsing process, but in in this in that rinsing process, um, etchant is still be having an impact to wafer. So it cause of um, uniformity problem. Then another problem is if uh, if if chemical reactions occur very well in certain area, then there is there is uh, there is consumption of reactants is very highly uh, than each other's side. Um, then in other area, uh, the reaction is less than before area, so it cause uh, uniformity problems. Okay, thank you.